I'm about to give an AI full access to my production code base, and I'm not even slightly nervous. That sentence should make you uncomfortable, because the default relationship between a developer and an AI coding agent is built on blind trust. You type a prompt, the AI starts writing files, running commands, and you're just hoping it does the right thing. Most developers deal with this in one of two ways. Either they approve every single action manually, which kills the speed advantage entirely, or they turn on full auto mode and pray nothing goes wrong. But there's a middle ground, a way to give an AI real autonomy while keeping hard limits on what it can actually do. Today, I'm going to show you plan mode and hooks in Claude Code, two features that change the trust equation completely. Before we dive into the details, let's understand the full permission spectrum that Claude Code offers. There are 4 modes, and they form a dial from maximum safety to maximum speed. Default mode asks your permission before every single action. Every file write, every shell command, you have to say yes. It's safe but painfully slow for big tasks. Plan mode is the sweet spot for complex work. Claude reads your code base, thinks through the problem, and presents a complete plan before touching anything. You review once, approve once, and then it executes. Auto-accept edits lets file changes happen automatically but still asks before running shell commands. Good for tasks where you trust the code changes but want oversight on commands. And then there's YOLO mode. Everything runs automatically. Maximum speed, zero guardrails. Use this only when you truly know what you're doing. Let's look at plan mode in action. You launch Claude Code with the flag -- mode plan, and now everything changes. When you give it a task, like refactor the auth module to use JWT tokens, Claude doesn't immediately start editing files. Instead, it reads your code base, analyzes the dependencies, and produces a structured plan. It tells you exactly which files it will create, which ones it will modify, and in what order. You can see the full scope of the change before a single line of code is written. If something looks wrong, like it's about to refactor a file you didn't want touched, you just say no and redirect. This is fundamentally different from watching an AI edit files in real time and trying to catch mistakes as they happen. With plan mode, you're reviewing strategy, not babysitting execution. You approve the what, and Claude handles the how. Why does this matter in practice? 3 reasons. First, you catch mistakes before they happen. If the AI misunderstands your project structure or makes a wrong assumption about your architecture, you see it in the plan, not after it has already rewritten 6 files. Second, architectural alignment. Your project has conventions, naming patterns, file organization, testing strategies. The plan lets you verify the AI will follow them before it starts. Third, and this is counterintuitive, plan mode actually saves time. A 30-second plan review prevents 10 minutes of undoing work that went in the wrong direction. I've seen developers lose an hour to rollbacks that a quick plan review would have prevented entirely. My recommendation: use plan mode for any task that touches more than 2 or 3 files. For simple fixes, auto-accept is fine. Now let's talk about hooks. If plan mode is about strategic control, hooks are about automated enforcement. Hooks are custom scripts that run at specific points in Claude Code's lifecycle. If you've ever used Git hooks, same idea. But instead of triggering on commits and pushes, these trigger on AI actions. There are 4 hook points. Pre-tool use runs before Claude executes any tool, like writing a file or running a shell command. This is your gatekeeper. Post-tool use runs after a tool completes, perfect for automated linting, formatting, or running tests. Notification fires whenever Claude wants your attention. You can route these to Slack, email, or a desktop notification, and stop runs when Claude finishes a complete response turn. The key insight is that hooks are just shell commands. Anything you can script, you can hook into Claude's workflow. The possibilities are wide open. Here's your first practical hook: auto-linting after every file edit. In your project settings.json, you define a post-tool use hook. The matcher targets write and edit tools, meaning it fires every time Claude creates or modifies a file. The command runs auto-lint with the fix flag on whatever file was just changed. Here's what makes this powerful. If auto-lint finds and fixes issues, great, it happens silently. But if there's a lint error that can't be auto-fixed, the hook's output gets fed back to Claude. Claude sees the error, understands it, and fixes the code automatically. You just created a feedback loop. Claude writes code, the linter checks it, and if something's wrong, Claude corrects it, all without you lifting a finger. Here's a hook that acts as a hard safety net, a pre-tool use hook that blocks dangerous commands before they execute. You write a simple guard script that checks the incoming command against the block list. If Claude tries to run rm-rf/git push force, drop table, or pipe curl into bash, the script exits with code 2. Exit code 2 is special in hooks. It means block this action entirely. Claude can't override it, can't work around it. This is not a suggestion or a warning. It's a wall. The command simply does not execute. Think about what this means for your workflow. You can give Claude broad shell access, let it install packages, run builds, execute tests, and know with certainty that the truly destructive commands are physically impossible. The third hook pattern is my personal favorite. Automatic testing after every change. When Claude edits a source file, the post-tool use hook runs the test suite, but only the tests related to the changed file. No need to run the entire suite on every edit. Watch the terminal output. Claude writes the email validator, edits the sign-up form, and immediately the hook kicks in. 14 tests run. All pass. Claude continues to the next step without pausing. But here's the real magic. If a test fails, the hook returns a non-zero exit code, and the failure output goes straight back to Claude. Claude reads the test failure, understands what went wrong, and fixes the code. It's a self-correcting loop, test-driven development enforced automatically. Now let's put it all together. Plan mode plus hooks gives you what I call supervised autonomy. Here's a real workflow. You ask Claude to migrate a database from Postgres to MySQL. Claude produces a detailed plan, 12 files, schema changes, migration script, rollback strategy. You review it, everything looks right, you approve, execution begins. The pre-tool use hook is watching every shell command, blocking anything that could drop a database without proper safeguards. The post-tool use hook runs migration tests after every file change, catching issues in real time. You're not watching every keystroke, you're not approving every file, but you have strategic oversight from the plan and automated enforcement from the hooks. The AI has real autonomy and you have real safety. That's the balance. Let me show you a complete settings file that ties everything together. At the top you have permissions. The allow list specifies tools Claude can use freely, like read, glob, grep, and running npm test. The deny list blocks specific dangerous patterns outright, like rm-rf and force push. Below that, your hooks. Pre-tool use runs the guard script before any bash command. Post-tool use runs related tests after any write or edit. And the notification hook sends desktop alerts when Claude needs your attention. This file lives in your projects.claude directory. It's version controlled, so your whole team shares the same safety configuration. No one has to remember to set it up. It's just there. Notice how permissions and hooks complement each other. Permissions are the broad rules. Hooks are the automated enforcement layer. Together, they form a complete governance system. So let's bring it home. Plan mode gives you strategic oversight. You see the full scope of what the AI intends to do before it starts. No surprises, no unwanted side effects. Hooks give you automated enforcement. Linting, testing, command blocking, all running in the background without any manual intervention. Together, they let you trust an AI with real work, not blind trust. Not hoping for the best, structured, verifiable, enforceable trust. You stay in control of the what. The AI handles the how. and hooks make absolutely sure it stays within the boundaries you defined. Getting started takes 5 minutes. Launch Claude Code with dash mode plan for your next complex task. Open your settings.json and add your first hook. Start with auto-linting, it's the easiest win. I want to see what you build with this. Drop your hook configuration in the comments below. The most creative setups, I'll review them in the next video. If this helped you rethink how you work with AI coding agents, hit subscribe, turn on the bell. We're going deep on Claude Code workflows, and there's a lot more to cover. See you in the next one.